We're going to switch our attention from just equations to functions. The definition of a function from A to B, where A is called the domain and B is called the range. So to be a function, to each element in A, there is exactly one element in B that is assigned. You can represent a function with words. You can represent a function symbolically. That's using f of x equals. You can represent a function graphically, and you can represent a function with ordered pairs that satisfy the criteria of the function. Let's take an equation, something that should be familiar to us. X squared plus y squared equals 4. Graphically, that's a circle with radius 2. Oh, pretty ugly looking circle. I've shown it graphically. Here it is symbolically. Um, to each element in the domain, X is usually considered the domain. I can see that more than one element in the range has been assigned. So when X is 1, there's Y up here and Y down here. So it's not meeting the definition of function. It is also not meeting the graphical sort of necessity of function. You may remember something called the vertical line test. If you draw a vertical line and pass it across your function, if it really is a function, it will never intersect your graph in more than one place at a time. So we're seeing that we're intersecting our graph in more than one place at a time. So this is not a function. Algebraically, I could not solve this for y. Y squared equals 4 minus x squared, square root both sides. Y equals plus or minus. See, it's showing that whenever I choose an x value, I will get 2 y values. So it is not a function. The current temperature is 15 degrees and it is dropping by 2 degrees per hour. Those are words. Let's see if I can create a function for that. So the current temperature is 15 degrees and it is dropping by 2 degrees per hour. And let's say x stands for hours. Okay, so we could say y equals. If I were to graph this, oops, let's give myself some space. Okay, it would graph 2, 4, 6, 8, 10, 12. I need more space. Oh, there it is. 2, 4, 6, 8, 10, 12, 14, 15. Okay, I want to be right there. Stop. 15. Down 2 over 1, down 2 over 1, down 2 over 1. So we get that particular graph. So we've got words, we've got a symbolic representation, and if I try to do my vertical line test, if I pass this vertical line, it never intersects the graph more than once, so this is a function. I could write this as f of x is equal to 15 minus 2x. So as a function of hours, I can find the temperature. I could also do several ordered pairs. At time 0, the temperature is 15. 1 hour later, the temperature is 13. 2 hours from the start, the temperature is 11. Like that. What do I do with functions? Well, I could evaluate them. So if f of x is equal to 2x squared minus 3x, what is f of negative 4? Well, that would be saying that x is negative 4. So 2x is negative 4 squared minus 3, x is negative 4. Negative 4 squared is 16 times 2 is 32. Negative 3 times negative 4 plus 12. So f of negative 4 is 44. How about f of 5? Now I'm going to substitute 5 in for x. So 2 times 5 squared minus 3 times 5. 5 squared is 25. 50 minus 15. So f of 5 is 35. How about f of a plus 4? So I'm going to substitute a plus 4 in for x. So 2a plus 4 squared minus 3a plus 4. So 2 times a squared plus 8a plus 16 minus 3a minus 12. 2a squared plus 16a plus 32 minus 3a minus 12. 2a squared plus 13a plus 20. That would be f of a plus 4. This is called a piecewise function, which says I have a function, but it is kind of a Frankenstein. It's defined in pieces of other equations or functions. So here's how it's read. F of x is equal to x plus 9 if x is less than 3. So anytime I want to use a value of x that's less than 3, I should plug it into this piece of the function. X squared minus 2 if x is greater than or equal to 3, but less than 6, and 7 if x is greater than or equal to 6. So it's defined in 3 pieces, and there's no overlap in these pieces. X is either less than 3, it's either 3 up to 6, but not including 6, or it's greater than or equal to 6. So let's see how this works. I want f of negative 4. Well, that's saying x is negative 4. So negative 4 is one of those values that's less than 3. So I'm going to plug my negative 4 into this piece, negative 4 plus 9. So f of negative 4 is 5. F of 5. Well, 5 isn't less than 3, but 5 is between 3 and 6. So I'm going to plug that 5 in to the middle piece and end up with 23. F of 6, well, 6 isn't less than 3. 6 isn't less than 6. 6 is actually equal to 6. So I'm going to plug the 6 into this piece. Well, there's nowhere to plug it in. So f of 6 is just 7. Let's take the function f of x is equal to x squared plus 7x plus 12. There's a difference between f of 0 and f of x equals 0. F of 0 means x is 0. So 0 squared plus 7 times 0 plus 12. So that would be 12. F of 0 is 12. Find the values for which f of x equals 0. Well, f of x is this whole thing. X squared plus 7x plus 12 equals 0. Oh, well, I put on my good factoring skills. So this product is equal to 0, so either x plus 3 equals 0 or x plus 4 equals 0. So x equals negative 3 or x equals negative 4. Those are the values for which f of x equals 0. In essence, f of 0 is finding a y-intercept. F of x equals 0, finding the x-intercepts. Okay, that is it for today.